Balu Balakrishnan, you're the CEO of Power Integrations. Thank you very much for taking the time with me. So, after acquiring CT Concept in 2012, Power Integrations has now also IGBT drivers in its portfolio. Some weeks ago, you presented the first Silicon Carbide driver circuit. So tell me more about why you came out with this Silicon Carbide Mosfet driver.
Well, the main reason is customers want it. The Silicon Carbide is doing very well. It's actually ramping a lot faster than I expected it to. It's driven primarily by automotive applications, where the benefit of silicon carbide is appreciated because its size and weight and cooling, all of that matters in automotive applications. So we expect the demand for silicon carbide to grow very rapidly, and so we decided that we have to offer a driver that is specific to silicon carbide because it's a very different device.
So can you tell me a little bit more about the differences between driving the IGBT and driving a silicon carbide MOSFET?
Well, fundamentally, silicon carbide is much faster, so you have to worry about handling the speed. Number two, silicon carbide die size is very small. It's about 1/5 the size of a MOSFET or an IGBT, which means that the thermal mass is very small. If you have a short circuit, you have to make sure that you turn the device off faster, 5 times faster than IGBT, for example, which means that you have to have a driver that can not only detect the fault reliably quickly, but also turn off the device in a way that it doesn't exceed the breakdown voltage of the device. So it really requires a special type of driver to do that. And it took us some time to figure out the best way to do that. But there are also other differences. Unlike IGBT, where most of the manufacturers, in fact all of the manufacturers, have the same drive voltage, that's not true with silicon carbide. Different manufacturers have different drive voltages, positive and negative. And so you have to be able to handle that also.
And so how the new Scale I driver family addresses all these needs?
First of all, we have a very advanced detection of overcurrent and short circuit. And then we also have an advanced clamping system that allows you to turn off the device very quickly at the same time in a way that the voltage on the drain is not exceeded. Okay, and that actually takes quite a bit of clever circuitry to do that. And it'll, I can go into more details, but it'll be easier to explain it with the figures.
So another very innovative component you brought out at Electronica is the BridgeSwitch. So there is a half bridge and a control circuit. This is not new by definition, but it's very innovative. So what do you think is novel in the way BridgeSwitch is solving this issue?
Well, the number one is efficiency. We have developed a switch that is extremely efficient, not only in when it's conducting, but also when the diode, the reverse diode is conducting. The reverse diode has very, very soft switching characteristics, which dramatically improves efficiency. We can get efficiencies of 98.5% for the conversion in the 30 to 300 watt range. We don't know of any other solution that can do that. Secondly, we manage the thermals because it's very highly efficient. It has very little heat, and we also spread the heat out into 3 different chips for a 3-phase converter, and it's in surface mount packages, so you don't need a heat sink all the way up to 300 watts. People don't like heat sinks. They are the least reliable part of the system. They can fall off, they can get disconnected, and so on and so forth. So we have found a way to completely eliminate the heat sink all the way up to 300 watts. It also has other features. Probably the most important one that people like is hardware safety protection. Currently, most people implement safety through software for IPMs. And unfortunately, when you do that, you have to get UL approval on the software itself. That means once you get UL approval, you cannot make changes to the software without going back to UL to get approval, which is a long process. So people really don't like that. They would like it to be able to upgrade the motor drive software, like algorithms and so on, without having to worry about safety approval. And so that's another advantage we bring.
So you said also that there is a special diode within which has totally different characteristics as the normal parasitic body diode. Tell me more about that.
Absolutely. The normal MOSFETs have really terrible diodes, especially for this type of motor control application where the full current flows through the diode. So we developed a transistor that is designed to have extremely soft turn on and off characteristics on the diode to improve the efficiency. And that's the technology we use in this BridgeSwitch.
Today you're announcing a new device. It's the InnoMux chipset. So this is the dream. You said the dream of all power conversion designers. What is this?
Well, I always used to wonder whether there is a way to build a single magnetic element power supply, like a transformer, one transformer, but provide voltages that are independently regulated. So people know you can build multiple output flyback, or for that matter forward converters. But the problem is you can only regulate one of the outputs accurately. The rest of it gets regulated through the transformer winding, which is not very accurate. Also, in some cases, you need some windings to be constant current, like if you're driving an LED in a back panel display. And obviously, if you're varying the voltage with the constant current, all of the voltages will vary, which is, of course, not workable. So the way they solve the problem is either using multiple power supplies or using a main power supply with multiple DC to DC converters following that. What we found a way to do, after a lot of thinking, is a clever way to use a single power supply to have independently regulated outputs, and any given output could be either constant voltage or constant current. It's actually mind-boggling to even think about it, that the same transformer is delivering on one output a constant current where the voltage can vary depending on the LED voltage and so on, temperature and so on and so forth, but the rest of them are absolutely stable. So that's what InnoMux offers.
So there is a very clever way of controlling the MOSFET, the primary side switch, and the flux link has a very big influence on it. Can you tell me a little bit about this control scheme?
So we have a control scheme that allows us to control the primary switch one cycle at a time. And what InnoMux does is every cycle that you get power from the primary, it decides where to deliver it on the output, which output to deliver it in to maintain it in regulation. And it is also made possible by the flux link technology, which has such a high speed connection between secondary and primary. We can do this cycle by cycle control. And that's how we are able to regulate all the outputs independently.
So, Balu, thank you very much for the interview.
You're welcome, Ralph.